The diagram shows the velocity time graphs for two athletes A and B who run in the same direction in the same straight line while they exchange the baton in a relay race. A runs with constant velocity 10 meters per second until he decelerates at 5 meters per second and subsequently comes to rest at B. B has constant acceleration from rest until reaching his constant speed of 10 meters per second. The baton is exchanged after 2 seconds. Exchanged 2 seconds after B starts running, when both athletes have speed of 8 meters per second, and B is 1 meter ahead of A. Find the value of t for which A starts to decelerate. Calculate the distance between A and B at the instant when B starts to run. Okay, I think I've got everything here in the question then. The first thing is this is time 2 seconds. The first part is find t when A starts to decelerate. Well, A will start to decelerate here. So let's drop it down here then. We know the gradient is -5. So, and we know that this is 8 and this is 10, so this is 2, isn't it? So we've got a slope here. We've got a triangle, so I'm going to draw the triangle. So part 1 then, here. So let's just draw this triangle, but I'm going to draw it the other way around, because that will be, I know the tan of the alpha. The slope is -5, so tan alpha is equal to -5. This height is a negative height, isn't it? It comes down 2, so it's -2. And this distance here is the opposite. We'll label it as O. And we need this distance, because if we find out this distance here, the total distance, I mean time rather, and the total time here is 2. If we find out this time, we can find out the time that elapses until A starts to decelerate, which is here. So that's what we want. That's where we're heading. So here, oops, tan alpha equals -5, which equals the opposite, -2, over the adjacent, which I'll call it A, over A. So that tells us that A, move the A up, is equal to, and move the 5 down, 2/5, because the minuses cancel. So it's 0.4. So this distance in here then is 0.4. So the time will be the difference between 2 and 0.4, which equals 1.6. So answer then? Answer is equal to 2 minus 0.4, which equals 1.6 seconds. So that's part 1. That's the time when A starts to decelerate. Calculate the distance between A and B when B starts to run. Well, the area under the curve is the distances that A and B will travel. So we know how far B is ahead of A here, because it's 1 meter ahead. So the distance SA and SB. So let's work out SA. SA is equal to, that's the distance that A takes to get here, where the A is 1 meter behind. So that would be this area here, wouldn't it? Which is equal to 1.6. It's this rectangle. So it's base times height. 10 times 1.6 plus. Okay, that's that rectangle. Now this here, the area of this will be half of these two added together times the distance between them, won't it? So it's half of 10 plus 8. Half of 10 plus 8 times 0.4. So this is equal to 16, 10, 18 over 2 is 9, 9 4s are 36, so that's 3.6. So it's 19.6 meters. So I put SA up there because we can see it from the picture. SB on the other hand, this is the distance that B has travelled to get to here. And we've got base, half base, because it's a triangle, times the height. So it's half base, which is 2, times the height, which is 8. So that equals 8 meters. So part 2 then. So SB is 8, SA is 19.6. Let's just put them down. SB is 8, SA equals 19.6. So here's the distance. There's SA, there's SB. This is the A and B runner, the distances they travel. At the end, B is 1 meter ahead of A. So that distance that they're apart is 1 meter. The distance here is 8 from there to there. And the distance SA is 19.6, which is here. So answer is equal to, well, the answer is here, isn't it? It's this distance. How far is B ahead of A? So it's going to be 19.6, take away this distance here, which we know is 7, because it's 8 minus 1 is 7. So it's 19.6 then. Take away 7 is 12.6 meters. So B starts 12.6 meters ahead of A, and they meet when B is just 1 meter ahead of A, which is shown in that sketch.